Okay, here we go. Number 11. Okay, so I'm going to spend a minute on this. I don't, but we're not doing anything with warm-ups in the packet, so you can just copy them out. So this problem I was actually supposed to do on Friday, but I was scared to do it on Friday because I thought it was going to mess you up for your quiz. This is gonna seem like an extreme amount of time to talk about the little detail, but it's very important detail. These problems are different from factoring problems. These problems have to equal zero. Do you guys see the difference? The factoring ones have just the n squared plus 4n plus 3, and it says factor. These problems say solve. That doesn't mean that you're not going to use factoring to solve it. It just means you're going to go one step further, do the zero product property and find out what x actually can. So I'm going to do this one with you. So of course. And we'll just see the difference between what we were doing last week and what we're doing when it equals zero. Okay, so first I'm going to do box and diamond still for my factoring. This is the only one that's actually factorable out of these four. Okay, so to remind you, n squared goes in the first box. 3 goes in the last box. You multiply those two things to get to the top of the diamond. The middle term, the B term, goes on the bottom of the diamond. Okay, and then you think, what multiplies to be 3 and adds to be 4? 1 and 3, beautiful. So I'm going to say 1n and 3n. N times 3n is 3n squared. N plus 3n is 4n. And I'm going to take both of these and put them in the empty spots in the box. Does it matter where I put them? In what order? No. I'm going to get the same answer in the end, no matter what. Okay. Now, I like to do this with a Post-it. I think I told you guys. So I'll take a Post-it and I'll just narrow my focus down to the top two boxes. And I'll say to myself, what's the greatest common factor of those two? What do they have in common? What do they both have in common? N, beautiful. So I put an N out front. N times what is N squared? N times what is N? Beautiful, great job. N times what is 3N? And then we just do our check. 3 times 1 is 3. So we know we did it correctly. Okay, so over here, I'm going to put my factors from my box, but this time it's equal 0. So last week I had you stop here at the parentheses. This week it's now equal 0. Do you see the difference? I know I'm making a big deal out of it. So it's just, this is really important. Okay, now we're going to do what's called the zero product property, which is where you set them equal to 0 separately. So n plus 1 equals 0. N plus 3 equals 0. Minus 1. N equals -1. Minus 3. N equals -3. Okay, so this is the difference. When it says solve and it's equal 0, you go one step further from your factoring and you figure out what n is. Okay, so moral of the story. If the problem says factor, you're going to leave it in parentheses. If the problem says solve, you're going to do one step further and find out what the letter equals. Everybody okay with that? Okay. All right. Now, can you please find number 15? Scroll down a tiny bit. And I know you guys did some I stuff in math too, but I need to remind you how to do it. And there's only one fact that you need to be able to do these problems, and that is I squared equals -1. If you guys could please write I squared equals -1 and just box it somewhere in between number 15 and 16. Okay, the first thing I'm going to do is just pretend this problem is like any other problem and simplify. So 5i times 3i is 15i squared. And then I'm going to distribute the -2. -2 times -3 is +6. -2 times +3i is -6i. Okay, let me pause right there. Any questions about what I did so far? Does that all make sense? Okay, now because it's an I problem, you're going to hunt in here for any I squareds. And if there's an I squared, you're going to replace it with -1. So 15 times -1 plus 6 minus 6i. -15 plus 6 minus 6i. And then just going to combine those two guys. -15 plus 6 is -9 minus 6i. And that's the final answer. You can't get rid of that I. You can only simplify I squareds, not i's. Okay, anything you guys want to ask about 11 or 15 before we move to the domain and range page? Sure you're good? Okay. Okay. We're going to do problems 5 and 6. Remember that this is the x-axis, this is the y-axis. And I'm going to mark with red pen on the x-axis to find the domain. There is a dot here, so I'm going to put a dot on the x-axis at -3. There's a dot here, so I'm going to leave that one because it's already on the x-axis. There's a dot here, so I'm going to put a dot on the x-axis at 1. There's a dot here, so I'm going to put a dot at the x-axis at 2. And there's a dot here. I'm going to put a dot at the x-axis at 5. Did you guys all follow that okay? No? You just make dots along the x-axis wherever there's a dot. So like this dot, I drew one there. This dot, I drew one there. This dot, I drew one there. Okay, now because it's dots, we're just going to write x equals -3, -2, 1, 2, and 5. Those are where I have dots on the x-axis. -3, -2, 1, 2, and 5. Okay, now y-axis. There's a dot down here, so I'm going to put a dot on the y-axis. There's a dot here, so I'm going to put a dot on the y-axis. There's 2 dots here, so I'm going to put 1 dot on the y-axis. And then there's a dot up here, so I'm going to put that dot on the y-axis. Okay, so y equals -5, 0, 1, and 4. Okay, now take your original dots, the ones that were on the paper before you started, and draw vertical lines down them Do any of your vertical lines hit two dots at once? No. So that means it is a function. Just the black dots, just the black dots. Yeah, just the original ones. Sorry, yeah, there's dots everywhere. So I used a different color. Okay, anyway, number 6. All right, so x-axis, y-axis. We are going to be working with graphs that look just like this today. This is actually a perfect one for today. So on the x-axis, I can tell this arrow, this curve arrow is going to go to the left forever. And then it goes this way, it goes this way, it goes this way, and it stops here at 4 with a closed dot. Okay, when you have a one-sided arrow, you make an inequality. So you're going to say x is less than or equal to 4. If you forget which one is less than and which one is greater than, feel free to always look at my crocodiles up there, which are next to the whiteboard. They'll be there all year because they're my favorite. Okay. The range, one of my costumes was a crocodile for Halloween, and then I had like a greater than sign. It's great. It was great. It was awesome. Anyway, okay. Now, this arrow, can you guys all tell that it's going up forever, even though it's going to go up forever really slowly? Okay. So it's going to go up forever. And the graph exists here, and the graph exists here, and the graph exists here, and it stops. The lowest spot is right there. That's the lowest part of the graph. This one is a one-sided arrow also, which is y is greater than or equal to 0. Vertical line test. Did it pass? Yes. Oh goodness, we are now done with warm-ups. You can scooch your packet off to the side and grab your notebook. If you don't have a notebook with you today, that's okay. There is graph paper on the table over here underneath the window. Go ahead and grab a piece of that if you need to. By the way, if there's anyone who's like me and extremely meticulous, there are rulers over here in the pink. I don't actually know if it's the pink one. I think it's actually the blue one. It's the greenish blue basket. There's rulers over there if you want to make your lines straight and you don't have one. Hey, everybody. So we're going to do two of these today. We're going to do 1-13A and 1-13B. 1-13A, this is 1-13A. I'm going to do it with you completely from start to finish. 1-13B, I'm going to assign your group a problem to do together. So almost every group will have a different one. And I'm going to walk around and make sure you're doing okay. And it's just exactly like this, but you're just going to have different numbers in it. Okay. So, the first thing I want you guys to notice is I put little red dots next to these three X values. And that's because those are the ones that are going to come out as a whole number. I want you guys to, we're going to use our mental math skills to do these three in the table. So for this one, I'm going to say 3 times the square root of -5 plus 5 plus 2. Okay, do you guys all see what I did? I took -5 and I plugged it in for X right there. Everybody good? Yes. You're good? Okay. All right, so -5 plus 5 is 0. What's the square root of 0? 0. What's 0 times 3? 0 plus 2? 2. Okay, so this is the coordinate -5, 2, which is right here. Okay, now we're going to plug in -4. 3 times the square root of -4 plus 5 plus 2. Do you guys see what I did? I plugged in -4 for X. Okay. Mental math. -4 plus 5 is 1. What's the square root of 1? 1. 1 times 3 is 3, plus 2 is 5. So that coordinate is -4, 5. Okay, now we're going to do -1, 3 times the square root of -1 plus 5 plus 2. Okay, what's -1 plus 5? 4, square root of 4, 2 times 3 plus 2, 8. So that's the coordinate -1, 8. And you can kind of see the shape of this thing. It's supposed to look like the warm-up that we did. Why did I have you do this by hand when I'm going to teach you the graphing calculator? Well, you guys have a second quiz in this chapter. The second quiz in this chapter has a problem that looks like that. And you have to complete the table, but you only have to complete the whole number once. Remember, you don't have a calculator, so you're just gonna have to do the whole number answers. And I already put the X's there, so you're just gonna have to plug them in just like this. That's why I wanted to do that together real quick. So that so you see where those came from at least. And you can sketch the graph from there pretty well. But now I'm gonna teach you the graphing calculator part. Actually, that's not true. I want to talk about -6. What's gonna happen with -6? Yeah, it's going to be imaginary, which we just looked at in the warm-ups also. So this one is going to give you an error in the calculator because -6 plus 5 is -1. And the square root of -1 is I, and that's not something that we graph. Okay, how can you figure out where the first part of your table should start? Yes. Okay. How can you figure out the -5 without guessing and checking? what you do is you take this piece underneath the square root that's called the argument and set it equal to 0. Just like we did on the zero product property. And that will give you the start of your table of the ones that actually work. I'm telling you that now because when I give you your function to do, I don't have the X's listed. So you guys are going to do that bit of math to figure out where you should start your table. Does that make sense? Okay, now we're going to do the graphing calculator portion. So go ahead and grab your graphing calculator. This is going to be purely exciting. Turn it on, which is the bottom and the bottom left button. And the first thing you're going to do is hit the y equals button. Now you guys have, if you have one that has been used before, and you hit the y equals button, sometimes those plots on the top have like black boxes around them. Does anybody have a plot that's highlighted on their calculator? Okay, so what you're going to do is you're going to scroll up using the arrows and you're going to hit enter to turn it off until it looks like mine. So this is on, this is off. You want all three of those to be off. Does anyone need any help making all three of their plots off? Okay. So scroll down one spot to where it says Y1. So just go hit the down arrow so you're here. And we're going to type this in. So we're going to do 3 times the square root of x plus 5 plus 2. Start with a 3. Okay, the square root is located above the x squared button. Anything above the button, you have to hit second first. So hit second x squared. You're hitting second x squared. Okay. Now the X button on the calculator is located right next to the alpha button. It says X, T, theta, N. This one right here is the X button right next to the alpha. So put X plus 5. Then you have to use the arrow key to arrow out of the square root and then put plus 2 on the outside. Okay, I'm going to come around and see if anybody needs help. Good. And did you enter in? Anybody need my help? I'm the graphing calculator with for anything weird happens, just let me know. Okay. Now we're gonna look at 2 things with this. The first thing I want you to do is not the graph. I want you to actually look at the table first. So do you see where it says table above the graph button over here? So everyone hit second graph. Second graph. Okay, and then you can fill in the rest of your table. And I'm just going to round to the nearest tenth. So this is 6.2, 7.2. If you guys do not have these showing up, you can use the arrow keys to scroll up and down to like this, just scroll up and down to get more numbers. -6 should say error. And that's because you'd get a negative under the square root. And it will say error forever that direction. Okay, now fill in the rest of the coordinates on your graph. So -3, 6.2, -2, 7.2, 0, 8.7, 1, 9.3, and then you can see the pattern pretty good. Okay, last thing I want you to do on the graphing calculator is to hit the graph button without hitting second. Just hit the plain graph button. And then you can trace your dots to make it look like your graph screen. Okay, now what we're going to do is analyze the graph. This is the last part. So over here, we're going to list some traits about the graph. The type of graph is a square root. This is a square root graph. Square root graphs look like a curve with an arrow in one direction. What? How do you just hit the graph button right here? Oh, okay. Hit zoom 6. Everybody in the class, if yours doesn't look like mine, hit zoom and then 6. It'll get you back to the original screen. Did that work? Okay. Did you use zoom 6? Okay. All right. So type is a square root graph. The shape is half a parabola on its side. The shape of this is half a parabola on its side. If I continued this graph to make the parabola, it would go down here and it would be a sideways, like we call it a sleeping parabola. Okay. The domain. This is a really great example of why domain and range matters. Where do the errors stop for the x's? -5. So x is greater than or equal to -5. And you can also do this graphically, just like we did on our domain and range worksheet. Okay, and what is the lowest value of the y's that there are? 2. Y is greater than or equal to 2. which you can also see graphically. Is this a function? Yes. Okay, we have a couple more things. What is the x-intercept? It's actually a trick question. There isn't one, yeah. What's the y-intercept? Yes, 0, 8.7. So when you guys do your problem on the graphing calculator, make sure that your table goes all the way to 0 so that you can put your y-intercept. Okay, what is the end point of this graph? Yep, that's where our graph starts, -5, 2, and where our table starts. And then the last thing I'm going to ask you is this function increasing or decreasing as I move to the right? Increasing. Okay. That is the entire number of problem 13A. I'm going to give you guys one to do in your groups. You can go much faster than, we're not going to the bathroom right now. We're going to give you one to do in your group. So I'm going to put the screen up and I'm going to assign them. Okay. Let me zoom in on this page. Let me not zoom in that far. Okay, are you ready? Okay. Table 1 and table 5 are going to do odd. So write down the one for odd. Table 2 and table 6 are going to do I up. You guys see that you have table numbers in the middle of your table. Table 2 and table 6 are going to do I. Okay. Table 3 and table 7 are going to do IV. And table 4 and table 8 are going to do VI. Now, okay, so first, type it in the graphing calculator, get the table, graph the dots. I would type it straight over Y1. I would replace my Y1 with this one because otherwise it'll get confusing. Excellent question.